उसके साथ ही मिलता। अरे मैंने कॉल लगाया नंबर दिया Mr. Kunal, Mr.
Yes,
Kun, can you hear me and you are comfortable with the board? Board is visible and audio is also visible?
Yes, sir.
Okay. So you make the figure and then we'll start. चालू करो. Today we are derive the differential equation of equilibrium. Consider equilibrium of small rectangular block. You write down. Kunal, you give me the response.
Yes, sir.
You open. Keep your mic open and give me the response. Consider equilibrium of the small rectangular block. You write down of edge h and k. Small h, small k, as it is clear from the figure. And unit depth means the depth is 1. Stresses acting on the sides 1, 2, 3, 4. Stresses acting on the sides 1, 2, 3, 4 are shown in the figure. These are the sides 1, 2, 3, 4 and the stresses acting on these show sigma x in the x, this is the x direction, this is the y. So sigma x on side 1 therefore 1, sigma x on the side 3 3, sigma y on the side 4, sigma y on the side 2, then the shear force tau xy on the 1 similarly. On account of variation of the stresses, ऐसी स्पीड पे आप ये भी चला सकते हो यार, बढ़िया स्पीड है. On account of variation of the stresses, through the material on account of variation of the stresses. कुणाल
यस सर।
लिख रहे हैं?
यस सर लिख रहा हूँ। एक बार लास्ट लाइन एक बार बोलिए।
On account of the variation of the stresses throughout the material, the value of stress sigma x, the value of stress sigma x is not same for phase 1 and phase 3. If capital X and capital Y, if capital X and capital Y are the components of external body forces, these are the internal force, and the capital X and capital Y are the component of the external body forces per unit volume.
Yes.
The equation of equilibrium for the forces equation of equilibrium for the forces in the x direction. I always in my every class I mentioned the forces are per unit length or per unit area. So to these stresses, so to find out the force we multiply by the length. So in the x direction, how many forces are acting on the x direction? This force, this shear force, this shear force. So taking the equilibrium in the x direction. So sigma x1 into, it is acting on the side k. This is the k, this is the h, this is the square. So this is also rectangle. So this is also k and this is also h. So multiply by the length k minus sigma x3 multiply by the k plus tau xy 2 multiply by the side h because it is acting on the h, tau xy 4 multiply by the h. These are the internal forces. Now I just told you the external force are x, component are x and y. So in the x direction, x multiply by the volume. So h into k into 1 is equal to 0. This is the equation of equilibrium in the x direction. Kunal?
Yes sir.
Understood? Equation of the equilibrium in the x direction. All the forces acting in the x direction we write here with the sign plus and minus. Okay?
Okay.
Now divide the equation with the h and k. Divide the equation by h and k. Okay, we can rewrite. Agreed?
सर 1 मिनट से लिख रहा हूँ.
हाँ, ओके ओके, नो प्रॉब्लम. हो गया?
Yes sir.
Now you write down, if the block is taken smaller and smaller, this block, if we take smaller and smaller, if the block is taken smaller and smaller, means h tends to 0 and k tends to 0. To make it small, h tends to 0 and k tends to 0. If h tends to 0 and k tends to 0, this becomes del sigma x upon del x, del tau xy upon del y, plus x is equal to 0. It is not 0 h and k, it tends to 0, it is very near to 0, then the quantity becomes the delta. So delta sigma x minus sigma becomes the delta sigma x, and this becomes the. Similarly, you write down for the y, just copy and you tell me what about the y.
Yes sir.
This thing you can do in the x direction, and similarly in the, if you will do in the y direction, so you will get similarly del sigma y upon sigma y plus del tau xy upon sigma x. Just you replace x by y, plus y is equal to 0. This is equation number 18. Now equation numbers are very important in my subject, because as this subject is connected, as we go further and further, and then we ask you to refer the previous equation. So you clearly write down the equation number every time. Should I rub this?
Yes sir.
Now, these are the differential equation of equilibrium for the two-dimensional problem. You write down. These are the differential equation of the equilibrium for the two-dimensional problem. Consider any body, then weight of the body is the only force. If some bodies, we consider any body, then the weight of the body, we not apply any forces, then the weight of the body is the only body forces acting on that body. Okay? If the mass of the body is, what you call this? Density. Density का क्या है? This symbol is weight is equal to mg. This is weight is equal to always mg multiplied by the gravitation. So in the x direction there is no body force, so x become 0. So in equation 18, put the 0 for the x is equal to 0. This x. What about the y direction? Sorry, this is Can you tell me about the y? Will it be 0 like x? Or not? What about the body force? I am putting the value here. This equation we are dealing with the any body which is subjected to the body for means only is its weight. So in the downward direction its weight is acting always in the downward direction. So y become the rho into g. Mg, as I told you, mass of the body, weight of the body is equal to m into g. Kunal. Who joined the newcomer? Newcomer is? Hello? Who is the newcomer? ऋषभ क्या? जोर से बोलो भाई. हाँ? तुषार. Okay. You are joining for my class for the first time? I am asking you. Will you give the response? Can you hear me, mister? Kunal?
Yes, sir.
Okay. The voice is clear, na? The Kushal is unable to hear. Kushal, give the response.
Hello.
हाँ. Why you are not giving the response? I am talking to you.
गाड़ी चला रहा था.
हाँ, तो गाड़ी चला के कैसे क्लास ज्वाइन करेंगे? This is not the formality, na? I will give attendance to you. No problem of the attendance. But you are doing the M.Tech with your own wish. B.Tech is compulsory, but M.Tech is on our own wish. So you should be sincere. Okay. Now this is the equation number 19. Now you write down the heading boundary condition. Boundary conditions. Equation 18 or 19 as we derive, just you write down equation 18 or 19 must satisfied at all the points. Equation 18 and 19 must satisfied at all the points throughout the volume of the body. Taking the previous that sigma x tau xy sigma y tau xy and external forces x bar and y bar. Name the sites. P, point P, this is B and this is C. PBC, PBC from the mass of the body, if consider the so x bar x bar is equal to x bar means this direction, sigma x into, I told you, the multiply by the length PC. The other force is tau xy multiply by the PB. Similarly, in the y direction, can you tell me, Kunal, in the y direction, sigma y, which forces are acting in the y direction? Y bar equal to, opposite forces are same in the, like this. Sigma y into PB, tau xy into PC, tau xy into PC. The force in y is this, these are the two forces in the x, these forces, these and these two forces. This is the equation 20. Now write down something. In the case of rectangular plate, coordinate axes are usually taken parallel to the side of the plate. लिखा कुणाल?
Yes, sir.
In the case of rectangular plate, coordinate axes are usually taken parallel to the side of the plate. Boundary condition 20 can be simplified. This means I want to tell you, if this is the plate, we can generally we take x, this is y. On the, for the rectangular plate, we take the parallel size x and y. Taking a side of this parallel to x axis, taking the one side is parallel to x axis. For this part of boundary, normal n, the force n, normal n parallel to the y axis, How? Suppose if we draw a separate diagram of this P, B, C, and this is the x direction and this is the y direction. This is the normal n, as it is clear from the figure. So if you want to take the n parallel to the y axis, means we rotate the side PC like this, and finally on the PB parallel to the x axis. So n become like this, means PC is equal to 0. आ रहा है समझ में कुणाल?
यस सर।
ये आया समझ में? नॉर्मल एंड को पैरेलल टू एक अभी फिगर बनाया था हमने, पैरेलल टू दिस इज द एक्स एक्सिस करने के लिए इस साइड को ऐसा 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 ले गए अप टू द एक्स एक्सिस. सो ये नॉर्मल जो इस पे तो इट बिकम्स लाइक दिस द न्यू कंडीशन. इन दिस केस द साइड PC इज 0. So put in the equation 20 what you will get? Equation 20 what you will get? X bar is equal to Y bar is equal to, क्या थी equation 20? If you put the PC is equal to 0, the first equation is plus minus tau xy, because the sigma x into PC is 0. PC is 0, therefore sigma x into PC is 0. Similarly for the y is equal to plus minus sigma y. Equation 20 becomes like this. Where we can this direction we can moving like this. Positive sign for the normal n, positive sign for the normal n towards positive direction. I will require the hard copy of my notes. The sessionals are depends upon the you will submit the hard copy of my notes. So you write down carefully. So positive sign of the normal n towards positive direction of y-axis and negative sign for the opposite direction of the y-axis. Positive sign for the normal n capital towards positive direction of the y-axis and negative for the opposite direction of the y. It conclude that, now you write down the conclusion. It conclude that at the boundary, the stress components become equal to the component of the surface forces. It conclude that at the boundary the stress components become equal to component of the surface forces per unit area of the boundary, per unit area of the boundary. So in the exam we ask about the boundary condition, the notes comes, so you should know what is the boundary condition. Equation 11 we proved. If you are able to see this is the question 1 of the 12 number. Already we proved equation number 11. This is this equation, and we also study the question number 1. A part is the state the assumptions made in the theory of the elasticity. States the assumptions made in the theory of the elasticity. So this is we already studied. Now if you taken the next question of the paper, second question, in the 2D problem, derive the following compatibility equation and differential equation. तो अभी क्या पढ़ा अपन ने, क्या पढ़ा? Differential equation of equilibrium, just we studied differential equation of the equilibrium, just we proved that del sigma x upon del x plus del sigma y upon del y plus x is equal to 20. This is the 18, means equation 18 is the solution of this question. Now the second question in this is compatibility equation. So we are now going to study about the compatibility equation. Yes. You should study hard in the M.Tech. You are going to get the degree of M.Tech. Huh? You have to sign the documents of the bridge design or something, building design, dam design, whatever. So it is, don't take it easy, take it seriously. Now the title is compatibility equation. Compatibility equations. This is also the important question from the examination point of view. You refer your previous note and can you tell me the equation 1 or 2? Equation number 2. Anybody can tell me the equation number 2? Kunal?
सर मैं एब्सेंट था उसमें,
तो रेफर करना चाहिए ना, एब्सेंट था तो अभी तक क्या किया? You should refer the previous notes from others. Then Vivek?
Yes sir.
Vivek, can you hear me? You give the response, Vivek. Kushal? Vivek and Kushal.
Yes sir.
Okay, okay.
Yes sir.
Kushal still driving the vehicle? Just
No sir.
okay. Now the compatibility equation number 2, as we studied in the first class, this is the equation number 2. Strain in the x direction, u is the displacement in the x direction divided by the small distance del x of any body. Then Ex is equal to del u by del x, Ey is equal to del v by del s, where the v is the component of the strain in the y direction, u is the component of the strain in the x direction, uv, and w is in the z direction. We are talking just now about the two dimensional only, therefore we are not taking in account the w. So u, v, w are the component of the strain in the x, y and z direction respectively, and the angular strain gamma alpha beta gamma, yes, gamma xy is equal to del u by del y. You remember here u is for the x direction but it comes y, and v is for the y direction but it is here x. So this is the equation. Now we have to prove that the equation of compatibility del square Ex upon del x square del y square, del s square Ey upon del x square is equal to del square gamma xy upon del x del y. This is the equation 20. With the help of these we are going to prove the equation 21, and which is called the equation of the compatibility. Okay. Now differentiate this with respect to y, because here we need the y. For the Ex we need the y. So differentiate this with the respect to y. Del Ex upon del y is equal to del square u upon del x del y. Still we have one more we require different, because this is x square del s square. So again differentiate with respect to y. Del square Ex upon del y square is equal to del cube u upon del x del y square. Say this is 1. यहाँ क्या करेंगे? Here you see that क्या करना पड़ेगा? Differentiate with the, looking to this y, differentiate with the respect to anybody, to get this from Ey we to get this will differentiate with respect to x. Very simple. Here it is, we require the x. So differentiate with respect to x. Del Ey upon del x is equal to del square v upon del y del x. Again, because we want the del square Ey, del square Ey upon del x square is equal to del cube v upon del y del x square. Say this is 2. आ रहा है समझ में विवेक कुणाल?
यस सर, आ रहा है.
ओके. Now to get this, to get this? Differentiate this with respect to, anybody tell me?
Sir, why?
Yes, why? Now the next differentiation with respect to, what is there in the 21? Del square gamma xy upon del x del y. We got the del gamma xy upon del y. Now what you want?
xy.
With respect to x? No, now we want the x. So here we will differentiate with respect to x. With respect to y and then with respect to x, del square gamma xy upon del y del x del cube u upon del y square del x del cube v upon del x square del y. Say this is 3. Add 1 and 2. Add 1 and 2. What you will get? Just this is a simple. You tell me equation A1 and 2. Add. One plus 2. This side 2 this side this side by adding 1 and 2 is there any relation with the third one? Can anybody tell me? Can you find anything about in this equation? Can you correlate with the equation 3?
Sir, x square and y square.
No. Means this we are getting here. The same thing. The same thing we are getting here like this. So this you can replace by this because this is equal to this. So you can replace this so we proved the equation of the compatibility as we written in 21. This equal to this because this is equal to. So we proved the equation. Okay?
Yes, sir.
If everybody is wrote, I want to rub the things. Should I rub?
Yes, sir. Left side का रब कर दो, right side का मत करना.
Okay. Equation number you must write 21 it was. You write down one line. This differential relation is called condition of compatibility. This differential relation is called condition of compatibility. It is written condition of the compatibility. Now, again the equation number, you refer to the equation number 3, equation 3. Equation number 3 you can refer. In the first lecture, I explained you that if the force is applied in the x direction, if the tensile force, suppose it is a tensile force, then the bar is expand like this. So in the x direction the stretch, but in the y direction it also affect in the y and z direction similarly. Okay, so if you apply the force in the one direction, it affects the body in all the three direction, because as you pull the thing, it length is increased but the volume is the same material, so it depth and width is shrinks. So the equation first says that this is equal to 1 upon E sigma x minus V sigma y sigma z. This is the equation number 1. It was 3. Equation number 3 it was. So you also carry the previous notes with you. So whenever I ask you equation number this, you must refer your previous notes to get that equation.
So this is your second class? So this is your second class?
No, this is my 4th class, I think. 4th class. Also you have to refer the another equations, previous equation number 5. G is equal to E upon 2 1 plus V. This was the equation 5. And gamma xy is equal to tau xy upon G. This was the equation 6. So these are the previous equations we are going to use in this proving the compatibility equation. Now, in the case of the two-dimensional stresses, sigma z becomes the 0. So this became, the equation remains like this: Ax is equal to sigma x minus sigma y. Similarly, Ey is equal to 1 upon E sigma y minus sigma x, like this for the two-dimensional cases. Now, what was, just can you tell me the equation 21? Just we proved. Equation 21. Anybody tell me, equation 21. Just we proved in this class only. Equation 21 of the same class. Kushal is there, but Kunal is not there. Okay.
मैं भी हूँ लेकिन
हाँ नहीं आप हैं, मुझे दिख रहे हैं, आप तो दिख रहे हैं सर, आप दिख रहे हैं मुझे. ओके, नो प्रॉब्लम सर.
एक चीज और रिक्वेस्ट मैं कर रहा था इन लोगों से कि जो लिख लेता उस दिन कम से कम शेयर कर दिया करें.
हाँ सर. यस सर. Right. Yes. I will share you my notes to you also. No problem. So just in equation 21 we proved this was the equation 21. Now put the value of this into this Ex and Ey. So you will get this is the Poisson's ratio. Always it gives the effect of the one force in the another direction. So this is the Poisson's ratio. Here also we put the value of this gamma xy with reference to this, and in this we replace the g with this value. So you will get this thing. We are just putting the value of gamma xy, like putting the value of Ex, Ey and gamma xy here, because it is the gamma xy. So gamma xy from the equation 6 like this, and in this put the value of g, so you will get the tau xy upon g means 2 1 plus v upon E. So E is everywhere, so you can cut the E. Now if you open the bracket, this is the equation B. This you can call as equation B. If you open this bracket, you will get del square sigma x upon del y square minus del square sigma y upon del y square multiplied by the v. V is here plus del square sigma y upon del x square minus v del square sigma x upon del x square is equal to same. Is anything is cancelling here? The similar thing, anything is similar? Also we put the value here also, del square tau xy का. Because we know that so if you open this, you will get multiply by 1 here, then multiply by the v. The lower part is visible, na? Minus del square sigma x upon del x square minus del square sigma y upon del y square minus v del square sigma x upon del x square minus v del square sigma y upon del y square. These things are cancelled, so finally we'll get equation number 24. If you open this, you multiply this by this term by these two, this term by these two, you will get the same thing. So previous one was the 21 was the condition of compatibility, and this is the equation of the compatibility. Now a very small thing, stress function. So we can start this use in the next lecture, the stress function, and we can start the new lecture in the next. To solve this equation, the scientist AIRY, scientist Airy introduced a new function phi, which is the function of x and y, 5. If we put sigma x as a del square phi upon del y square minus rho g y, sigma y is equal to del square phi upon del x square minus rho g y, and tau xy is equal to minus del square phi upon del x del y. This is equation number 29, where phi is the function of the x and y. Five minutes matter is there only, na? So we'll use it in the next class. Just we see the equation B, del square upon del x square plus del square upon del y square sigma x plus sigma y is equal to 0. As you will open, you will get del square sigma x upon del x square plus del square sigma y upon del x square plus del square sigma x upon del y square and del square y upon del y square is equal to 0. Just I open the bracket and this. Now we have to put the value of sigma x here, sigma y here, and sigma x here, sigma y. Simple. So differentiate with respect to x, because we need the, so del sigma x upon del x is equal to, with respect to x, del cube phi upon del y is already there, del x comes and this becomes 0, because differentiating with respect to x, though y terms it becomes 0. Again we want the square, so again we differentiate once more. Del square sigma x upon del x square is equal to del 4 phi upon del y square del y cube. This was the del y square, na? So del y square del x square. This is 1. Same thing we did in the last some equation. Now we need this one. So differentiate this y with respect to the x. Del sigma y upon del x, this is equal to del cube phi upon del x cube. Again del square sigma y upon del x square is equal to del 4 phi upon del x 4. This is the second.
बात नहीं की उससे, तुम डीजीपी से एसीपी से बात कर सकते हो, डीपीटी से बात करनी चाहिए.
Now for the sigma x, we differentiate sigma x with respect to twice sigma x. We already have this. Now we have the differentiate with the y. Now you differentiate with the x. Del 4 phi upon. Similarly for the sigma y, del sigma y upon with respect to y, del cube phi upon del x square del y, del square sigma y upon del y square is equal to del 4 phi upon del x square del y square. This is the 3 and 4. If you put the value of this thing, we have the sigma x, sigma y and tau x. Just we here the tau x y is not here, है ना? So only we use the sigma x, sigma y, sigma x with respect to twice x, sigma y with respect to y, x twice, sigma x with respect to y twice, and sigma y with respect to y. So 4 times we did. So 1, 2, 3, 4. If we put the value in B, equation B, this is the equation B, you will get the final one, del 4 phi upon del x square, del 4 phi upon del x square plus 2 del 4 phi upon del x square del y square. Here it is 4, sorry, I am 4. Del 4 phi upon del y 4 is equal to 0. This is equation 30. Del 4 phi upon del x 4, del 4 2 del 4 phi of del x square del y square, and del 4 phi upon del y 4 is equal to 0. This is equation 30. This will use in the next class as a stress function. So I think it is enough for the today. About the attendance, you speak the names. Kunal and Kunal and other is? Huh?
That Kushal Sharma.
Kushal.
Yes, sir.
Kushal, you come since means join the classes sincerely. It is a difficult subject, and I advise everybody, if they come in the this year offline, it is better. They will.
Okay, sir.
It is easy to understand the things.
Yes, sir.
Today is the date.
25.
25. Okay. Kunal and Kushal and Sir. Ranveer Singh ji. Yes, sir. 3 were there, na? And one Vivek Pathak, I think, is gone.
किस टेक्स्ट बुक को रेफर करना पड़ेगा सर? टेक्स्ट बुक को रेफर करना होगा.
इको आ रहा है, मुझे सुना ही नहीं दे रहा. क्या बोल रहे हैं?
आवाज नहीं आ रही.
हाँ, इको हो रहा है. इको बोलिए, या तो 2 माइक ओपन होंगे. बताइए कौन बोल रहा है? हाँ,
टेक्स्ट बुक का क्या करें? टेक्स्ट बुक कौन सी है?
तो I will share the notes also, but not, if I will share it, it becomes you should come in the class and you write yourself, so it is easy to understand the things. Therefore it is not advisable to share the notes. If you will go to home, if you will rewrite these things on the fair, you will be able to understand the things more easily. So I am telling you again and again, this is the difficult subject and you are going to become a master of the structure. So it is not the easy 10th class or 12th class like this. You should study hard and give the time. You should give the time to the subject and to the degree. Okay? Have a good day. Should I close? Yes. Okay. Thank you very much. Anything you want? Sir, you want to tell anything?
No, sir.
Okay. Thank you. Sir.
Namaste.
Have